Okay, guys. Attempt number 2 here. So, we did the equation equal to 0. We solved. We were talking about how 4 and negative 3 are the x-intercepts, the zeros. I asked if you guys had all gotten it graphed.
Yes.
And I was met with good response. I was getting ready to graph mine, I think.
Yes.
So I'm going to do x squared minus x minus 12. If we have a test Friday, you have to be able to use your graphing calculators for basics like this, right?
Oh, yes. So there's a chance we're not.
As of right now, that's my plan.
But plans have.
Okay, x squared minus x minus 12. We expect it to be a parabola. It's a parabola. If you notice right here, notice where it's crossing. Negative 3 and 4. Okay, now, my question becomes, because we're trying to solve the inequality. If we're solving the equation, my answers are 4 and negative 3, and I'm done. But we're solving the inequality. So go back to when you had the 0 on the right, and it was inequality, and this says greater than 0. And I talked briefly a little bit yesterday about what greater than 0 means graphically. Do you guys remember? Not right, because we're not looking for when x is greater than 0. We're looking for when that equation is greater than 0, which that equation is equal to y, essentially. So we're looking for when our y values are greater than 0, which means we're looking for when is this graph above the x-axis. That's the question we're asking ourselves. If it was less than 0, we want to know when is it below the x-axis. Since it's greater than, we're wanting to know when is it above the x-axis. Okay, so those are the questions you are asking yourself. Now, I'm going to put a sketch of the graph over here, just so I have something to draw on and point at and, you know, all that. We're crossing through at 4 and negative 3, right? Okay. So that is the sketch of the graph. And we can see right here that these are my zeros, my x-intercepts. It touches at negative 3 and 4. So where is this graph above the x-axis? What? Right, but we're not talking about shading here. Which pieces of this graph are above the x-axis?
It would be less than negative 3 and greater than 4.
It is. Okay. So Shiley's response was less than negative 3 and greater than 4. Because, okay, so as we look at this, what pieces are above the x-axis? And that is this piece to the left of negative 3, correct? And, whoops, I didn't draw my circle very well there, but that piece to the right of 4. So we have the pieces above negative 3 and above negative 4. If you think on a number line, which is what you have to, this is what your brain has to work like. That x-axis is a number line, yes? If that x-axis is a number line, then think about like if there was a, not even going to be able to see this because I already drew in, but like if there was just like dashed vertical lines at negative 3 and 4. Those parts that are above the x-axis are outside negative 3 and 4, right? So that means the one is less than negative 3 and the one is greater than 4. For instance, if we talked about what kind of ordered pairs are on this portion of the graph right here, it would be numbers, the x values would be smaller than negative 3. Maybe negative 3.5, negative 4, negative 5 would be x values. If we talk over here about what kind of x values represent this portion of the graph that is above the x-axis, it'd be things past 4, 4.5, 5, 5.5, 6, 7, 8.1, you know, whatever numbers you come up with there. And so, for that reason, our solution here then, it's numbers left of negative 3, So I'm going to use inequality notation for the moment. X less than negative 3. And if I have two different sections, is this an and or an or statement? An or statement. So x less than negative 3 or x greater than 4. Coincidence or not? What was my original sign on this problem? It was a greater than. Greater than. So a greater than statement ended up, or a problem ended up with an or response. So that's the inequality. Can you think about interval notation there? What does x less than negative 3 look like in interval notation? Where would your shading start? Negative infinity, yes? Because if it's x less than negative 3, it's going infinitely off to the left. Negative infinity always uses a parentheses, comma. Okay, so we're talking about this portion here. Starts at negative infinity, x value. What x value does it end at? Negative 3. Parenthesis and bracket. Does it include negative 3? No. Officially, because this was just a greater than sign, you're not using the equal to. Okay, so it's parenthesis. Remember, or, we use the union symbol for set notation. And then what's x greater than 4 look like? Okay, starts at 4, goes to positive infinity, and both of those are parentheses. Okay? So we did two things here, or at least two steps I kind of want to put, is that we graphed the equation y equals x squared minus x minus 12. And then our question that we had to answer is, in this case, where is the graph above the x-axis? Those are your questions to think about. Okay? Questions on that one? I felt like it was very disjointed. We started yesterday, we started again today, then we had a fire drill, and yeah, an unplanned fire drill on top of it all. Hey, we're good for the month of September now. I can guarantee that's why they went ahead and had sex. So, okay, got what you need here? Flip to the back then and start thinking about that one. X squared plus 3x less than or equal to 20. We're trying to solve this. It's quadratic. What do you think a good first step would be? Okay, subtract the 20 because we're trying to make this so that it is equal to 0. So this is going to be rewritten as 2x squared, still plus 3x, but now minus 20 less than or equal to 0. Okay. In order to solve this and get our zeros, first of all, I'm going to change that less than or equal to an equal to. 2x squared plus 3x minus 20 equals 0. How do I solve this? What?
You have to factor.
If it would result in whole numbers, I would divide by 2. Since that's going to turn my middle portion into a fraction, I'm not going to divide by 2 because I'm hoping to factor. Now, in order to factor this, what do I have to do? Product of AC. We reviewed this last week, right? Product of AC means we're going to have a product of what? 2 times negative 20, so negative 40. A sum of 3. What multiplies to negative 40 and adds to 83. Positive 8, negative 5. What do I do with that positive 8, negative 5?
Split.
Split the middle term. So I'm going to split it as a positive 8x minus 5x. The 2x squared will just carry down. The minus 20 will just carry down. Still equal to 0. I've got 4 terms. Continue the process. What do we do? Split them in half. GCF of the first 2. I agree with 2x. So 2x, remaining in the parentheses is x plus, not 8, 4. GCF of minus 5x minus 20.
5. Negative 5.
Negative 5, because both of those terms are negative, right? If we want this to work out matching the other half, we go with negative 5. And honestly, anytime that x term right there is negative, I go with negative 5. So if I factor out negative 5, negative 5x divided by negative 5 is x, minus 20 divided by minus 5, plus 4. Success because
They're the same.
parentheses match. So one of my parentheses,
2x minus 5.
my GCFs of 2x minus 5, other parenthesis,
X plus 4.
matching x plus 4. You pretty much know what your zeros are, but officially the step is to
Set both equal to 0.
set them both equal to 0. So 2x minus 5 equals 0. X plus 4 equals 0. So if it's 2x minus 5, can we do that in our heads? Add 5, divide by 2. You guys are telling me 2.5. I was going to write it as 5 halves. We're on the same page though, right? I don't care, honestly. And if it's x plus 4, it's x equals negative 4. Okay. So what is this 5 halves and negative 4?
Those are x-intercepts.
X-intercepts, right? That's where when I graph this, my graph is going to cross the x-axis. Now, what is the question we're trying to ask ourselves here? Okay, so the last problem, it was when is the graph above the x-axis. This time, my equation is less than or equal to 0, so we want to talk below the x-axis. Okay, and I'm not saying, you guys can't even see what I wrote there. I'm writing these questions down just as when you go back and look at this problem later, you can, where did I get this answer? What was I asking myself? But you guys don't have to write those questions down, but if you're going to question it later and be like, what did we do? Write the questions down, right? Okay. Have you graphed it? Graph the equation of when it was equal to 0. So 2x squared plus 3x minus 20. And then I'm going to hit graph. Surprise, surprise, I have another parabola. Not a surprise is my point. Surprise, surprise. Where's my graph crossing the x-axis? Negative 4 and between 2 and 3, which we're going to assume without checking that is 2.5. Okay. Again, for visual purposes, I am sketching my graph here. Yes.
Can we technically just after we get 2x squared plus 3x minus 1. Can we just put that out of the graph and then I get our calculator and get our 2x's?
Hold that thought for the next problem, please. I will address that.
Okay.
I'm not going to answer it right now. I will address it. You're just a step ahead of me. Okay? Okay. So we have this parabola going through -4 and 2.5. Yes? Okay. So now, the question was, where is my graph below the x-axis? So what section am I talking about here? Where's my graph below the x-axis? The bottom part of the parabola, right? The bottom part of the U-shape? And think. Okay, so if you visualize, like think number line wise, that portion that is below the x-axis, where is it at in relation to -4 and 2.5? It's what?
In between.
In between, yes? Yeah. So it's all numbers that are greater than -4 or, and less than 2.5. So we can write this a couple of different ways here. But again, we're looking right there, yes? So it's all those numbers on the number line between. If I think in terms, okay, real quick before I write this down, I'm going to write down that this is the equation that we graphed. Okay, we graphed the equation that equals 0. So, I said, the answer was between. How do you guys generally write between? Yeah, can you just put x in the middle? It's less than 5/2 and greater than -4. However, notice I put equal to's on mine. Why did I put equal to's on mine?
Because that's what it has to do.
Because that's what they gave us, right? If they give you equal to's, you use equal to's. If they don't give you equal to's, you don't use equal to's.
So both will be equal to the number
Because because that's what they gave us. So really what this comes from, if you think about it, was x greater than or equal -4 and x less than or equal to 5/2. What does this look like? I mean, this is our inequality. What does this look like in interval notation? Where does my answer begin? At -4. Where does my answer end? 5/2. So -4, comma, 5/2, or if you're using 2.5, that's fine as well.
Couldn't you still over 1 time that be that?
It would be.
Okay. We just did that for
It's not what I meant to do.
yeah.
Brackets or parentheses, did I already ask that? Brackets because it was equal to, right? Okay. Questions on this particular problem? Okay. And several of you are already catching on to where we're going next, okay? This section that we were just doing was solving quadratic inequalities, okay? They were designed that we could very easily and nicely solve them algebraically first, right? Which, to an extent, you could have pretty much done these without graphing them on the calculator. Okay, if you know enough, you could have done that because you know, with it being a positive x squared, you know they're right side up parabolas, and you can base on, okay, what's above, what's below. Now, let's look at this next problem. And as I said, several of you are catching on and a step ahead of me, but I'm going to officially give you permission here. To solve simply by graphing, we find where the quadratic would cross the x-axis instead of factoring. So there's times in homework where you'll be asked to factor, and I expect to see a little bit of work, but there's times where you won't be asked to factor. And the reason being, x squared minus 4x plus 1. What do you know about that? Does it factor?
No.
No, I can't get a product of 1 and a sum of -4. So we don't have to factor. Okay, we can go straight to the graph. So your first step is going to be to graph. What is it we're going to graph? You got it. So I'm graphing officially y equals x squared minus 4x plus 1. Once I get it graphed, what portion of this graph are we going to be looking at for our solution? Okay, so we're going to have to look at for where it crosses the x-axis, but then our actual solution is going to be where the graph is what? Above. Because it says greater than or equal to, we are going to look above the x-axis. Okay? So, have you graphed it?
Yes. It's still not to tell the where it is.
Okay. So let me get my graph up here. And the first thing I would like to write down is what are these x-intercepts? Now, the last one's factored. They were nice, neat whole numbers, or the one had 2.5. Can you tell what these zeros are just by eyeballing it? No. Okay. Trace is one option, although I taught a more specific option than trace, and that's my preference. You can hit a button, and yes, it'll take you to the 0.
What do you mean to the button?
It will tell you the 0.
Oh, okay.
Okay, so do you guys remember the button? I can tell Ross did by is you hit a button.
Oh, yes, you just second and calc.
Okay, so second, calc, which is my trace button. Okay, so just clear out of there. Okay, go down to number 2, 0, and start working on finding it. It will be, but hit zoom 6 and it will reset. There's supposed to be a -10 there. But if you hit zoom, that'll take you back to the page.
So it's
So
fine
you
out of
hit the second button and then you just
Yes. Okay, so second calc, are we all practicing?
Yeah, I got it.
Okay. Go down to 0. Now, remember, my calculator asks me questions. It's like it's talking to me. First question, left bound. So, if I'm trying to find this first 0, the one is between 0 and 1, I want my cursor to be to the left of that. It doesn't matter, you can go way over here if you want. That's still left bound. You can go all the way down there, right close to it. Any of those are left bounds. Hit enter. Now it's asking me for a right bound. So now you move your cursor past the x-intercept. You can move as far as you want. I just wouldn't go past the next x-intercept. Hit enter. Now it's asking me for a guess. You'll learn that a guess can often be ignored, but officially the idea is go back to the area that I'm looking for. Hit enter. We should get the same exact 0. 0.26794,919.
Yes.
Okay, let's go 2 decimal places on that. So x is approximately 0.27, correct?
Oh, mine rounded.
Yours rounded 1 decimal spot earlier. Okay, now what?
Go on to the other one.
Repeat the process, right? So second, calc. Number 2 or 0. Now your left bound has to be left of the other one. So it's below it. Right bound is past it or above it. Guess, you backtrack to that ballpark area. And did you get a matching 0 with me? Yep, 3.7320508 is what mine says. So if I go 2 decimal places, that is 3.73 approximately. So I'm going to write a side note over here. Do you need a reminder of how we just did that? Some of you are going to say yes, some of you are going to say no. So to find x-intercepts, I do second calc, and then I go to my 0 option, where it says 0. Okay, so if you need a reminder of what we just did, as I said, if that is a skill you have to be able to do on the test. So if you have not yet practiced that skill, get practicing. And please don't wait till Friday morning before school to get practicing that skill. Or Friday at the beginning of class. Okay. Now, if I sketch my graph in here, and again, just so I have something to, this is not a very good parabola. I'm just trying to get in the fact that there's a parabola, 0.27, 3.73. Okay, there's my sketch, so I have something to draw on. What's my solution? Which sections are greater than or equal to 0? The two outside pieces? Okay, so think about it. I keep trying to draw a vertical line in here. How does that relate to 0.27 and 3.73? It's numbers that are what? Less than 0.27 and greater than 3.73. Are you seeing that? So I'm going to write x less than, do I want equal to? Yes, so less than or equal to 0.27 or x greater than or equal to 3.73. Okay, with that in mind, interval notation. If it helps, guys, think. You're just thinking about a number line here, right? So it's 0.27. So it's everything left of 0.27. And then it's 3.73. Everything right of 3.73, yes? You got your interval notation in? You don't have to draw that far on the graph if you don't need it, but where's my interval start at? Negative infinity to where? 0.27. Negative infinity has parentheses. 0.27 has bracket. U for union. Next interval begins at 3.73 with a bracket. Ends at positive infinity, which always uses a parenthesis. Okay, I know I'm running out of time. Real quickly, though. Punch in the graph of 6 as soon as you can. What does less than 0 mean? Where's my graph below the x-axis? Did you graph it?
It's not below that.
It's not below the x-axis. So what's my solution?
0.
No solution.
What if we put 0?
That'd be wrong. The 0 is a number.
That's what I thought.
Okay, so what I real quick did here is I graphed y equals x squared plus x plus 2. And I'm going to say no solution. Why was there no solution? Yeah, well, it's not because there's no zeros. Because if we wanted greater than, if we were looking for greater than, it'd be all real numbers. Because everything is above the x-axis. But here, nothing was below the x-axis, so this is because the graph never goes below. So graph never goes below the x-axis. Okay. Obviously, that's my stopping point for today.
Is any of the bottom?
That's what I'm checking right now. So the question is, yeah. Okay. 33 and 34 go with projectile motion. I will assess what I want to do. Do the homework. So do 2 through 26 evens, please.
So we don't have to do that.
For the you can look at 33 and 34. For the moment, I haven't taught what goes with 33 and 34. I have to decide if I want to teach that tomorrow or what I want to do. Okay? Yes, I hear you, Carly. Homework is on page 58, and it's supposed to be 2 through 26 evens, 33 and 34. However, 33 and 34 are the pieces I did not get to. So 2 through 26 evens will be what you will be capable of doing. I have to decide. I'm going to see how this period goes and decide what I want to do about that. Okay? You're welcome. And Carly, the homework is always in Skyward if you ever need to look it up. You're welcome. Have a good day.
So, do we have a test? No, we don't. No, we do.
Thank you. Remind me if I don't manage to get it in grade book, but I'll try. Carly beat Eli for right now.
I have a question.
Thank you, Ashley.
How do I know?
Yep. Great or then. So great or means if it's a great or, you know, less than. If you put the emphasis on the, yeah, less than. There it is, right there. Is that what you need to know?
Yep.
Do you guys want your desk sprayed?
No, fine.
Yes, I'm more than willing. It's just I got caught up in between the period stuff and right here in Olivia. You guys want to spray from back here?
I'm just kidding.
I mean, I'm just the way it is. It's one of those things. Yeah, I get caught up in two periods at times, and then all of a sudden, oh, hey, there's enough to yeah, I think it's fine.
Hey, Sean.
Okay. You guys that are in here, work on having review worksheets. Have them out, ready to turn in. Pencil and calculator on your desk. Everything else can be under your desk. Cell phones on the back counter, please.
Already done.
Can I get a calculator on my office?
Wait. So you're not testing? Whatever. Yeah, work another. I don't know what to do. I don't, you know, it's whatever you feel comfortable doing. Okay. Eli. If you go on Schoology, you may be already looking there. If you go on Schoology, your test should be available there. I ask that you submit your answers there. Like, yes, you'll answer questions there, but what I will really be focusing on grading is your work. Okay? So, like, I want you to grab a piece of just normal lined paper or whatever, work the test out in there, and then send that to me via pictures at the end. Does that make sense? Okay? Okay, you guys in here. First of of all, if you're in here and taking the test, your cell phone, your cell phone period in the statement needs to be back there. Okay, so I will do a check. Did you silence them before you put them back there? Please don't have them so they're going to vibrate and drive those back people nutty. Okay. Review worksheet, I will collect as I bring you the test. Pencil, calculator, are your needs. Jaden? Yes. Sorry, I didn't mean to blind you guys. Yes, I can get calculators out here a little bit once I get everyone started on everything else. Okay, I'm going to come around. I guess if you're not quite ready, don't hand me your review worksheet. I won't give you a test. But other than that, I want to get you guys going as quick as possible. Okay? I posted the test link. I did all right. If I got it too long, the deal is the test needs to be finished during class. Okay? It's not something where you can come back and finish it another time. I'm assuming you're not testing. It's not my goal because it's a concussion protocol. That's not my fault. Does that make sense?
Yeah.
So if you are, if you're feeling at all headachy, I would definitely say no. Yeah. Then the answer is no.
Yeah.
I don't want to be, unless you just really feel the desire to take it and get it over with, which I understand, but, yeah.
Wait, did you need our notes?
I do not need notes. I'm just looking for review worksheets.
Oh,
I'm used to just passing the test back the road, but easier said than done here. Aiden, are you ready to test? Fine. Please remember to show all steps, show all work. That can earn you partial credit. That was just writing expression. And actually, this is an equal thing. Technically, you probably should put something there. Over there.
Okay.
Anyway, and I will answer that.
Okay.